Control Flow, Part 1 of 2. In this nugget, things with our Python programming really start to get interesting, because whereas up to now we've done pretty linear things in our procedural code, in this nugget I'm going to formally introduce you to the if statement, which opens up the world of conditional logic. That is, having your program go down different channels depending upon Boolean true or Boolean false values. Of necessity then, we'll need to discuss exactly what Boolean logic is and why Boolean operations form the basis of modern digital computer logic. Finally, we're going to look at break and continue. These give us even more control over how a branched Python program works when used in conjunction with loops and the if statement. Without any further ado, let's get to work. What is the if statement anyway? The if statement is popular not only in Python, but you can find if in just about every modern programming language, scripting language, and even end-user application. Think of Microsoft Excel. Excel has a built-in if function that enables you to do rudimentary decision-making, branching, and conditional logic. For instance, in an Excel workbook that you might have set up as a gradebook application, you could perform certain functions on certain cells depending upon the values of those cells. Doesn't have to be a gradebook, that could be any kind of business-oriented worksheet. If statement is good for that. The middle of the whiteboard gives us our basic syntax for using the if block or the if statement in Python. It's pretty straightforward actually. We have a really good foundation in the language now as far as what are called semantics are concerned. Semantics deal with how we apply the grammar of a programming language and what the syntax of that grammar actually means. So you'll notice that if is in fact a compound statement that consists of a colon header and then an indented suite. Now at base, you would have if and an else. The if gives us our initial test, and that test is always going to evaluate to one of two conditions, Boolean true or Boolean false. Underneath that if statement, you're going to have what happens if that test evaluates to true. Alternatively, if you don't just want to go to the else case, which of course in this case would be anything else, you can be more granular. For instance, you might have an if statement that asks the user to choose one of, say, 3 different paths. So your first test might test for the one case. You would then use not else if, but in Python it's called elif, to test for the second case, and then ultimately your closing else is what I consider to be a catch-all case, such that any condition that isn't formally covered by an if and or your elifs, you can have more than one of these by the way, will get captured by the else statement, and then indented under there you have your statement block. If you have experience with other programming languages, you're probably thinking, oh, this is exactly what C does with their switch statement, and you're exactly right. There is no formal switch statement in Python. There's actually some magic you can use with dictionaries and the get method to simulate the switch environment, and what we're doing now is showing you the formal if statement. In terms of our if or elif tests, we'll often, if not always, use some logical operator. We know what an operator is now. It's a symbol that performs action upon one or more operands to give us a result, and of course that whole deal, operators and operands, is what's called an expression. If we're dealing with equality, remember it's a double equals. If we're dealing with inequality or not equal to, we use the bang equals or the exclamation mark equals. Less than, greater than, less than or equals, greater than or equals. Now note that there's no space between those characters. Some Python programmers, or just programmers in general, like to pad their code with extra spaces. According to PEP 8, which remember is our style guide for Python coding, we want to avoid extraneous white space wherever possible. And in particular here with these operators, you absolutely cannot have any space between the equal sign and either the greater than or less than sign. And then finally you can do Boolean logical and, or not. More on those in just a moment. What you're looking at right now is a script file I created in idle called if2.py, and this is going to be our first simple test of using the if statement. I want to walk you through a couple things. One is going to be review, one's going to be new. You'll notice the first line of this script file I put the pound sign, which we normally associate with comments, one-line comments, And then you'll see I have bang and then a Nix path, a Linux Unix path, out to where the Python executable normally lives. The reason I'm bringing this into you is just so it doesn't appear shocking or a surprise or a confusion to you when you're looking at live Python code, in particular Python code that was intended for running on Nix systems. What this is, and I've included this in my documentation string actually just for grins, is what's called an exec hack. And what you'll use this for, if you want to, is to make it easier or more convenient to run this Python script from a terminal shell on a Nix system. So normally, and I'm going to demonstrate this a little bit later in this nugget, that if you were going to run a Python script from an OS shell, you would call the Python interpreter directly and then pass in the name of the Py file. If you have this exec hack up here, you're telling Linux in advance where to find the Python executable. So in this case, you could open a terminal shell and simply type if1.py to run the program. Okay, so now we've covered that. You also remember that the first unassigned string that the interpreter finds in a module is the doc string. So therefore, we can call the help function from the interactive prompt to give us this string that's contained within triple quotes. Enough introduction. The body of this script, what this mini program does, you'll note that first we create a name called num, and we're grabbing a string from the user, keyboard input, using the input function and asking for an integer. And then I could have wrapped this input in the int function. We've used that before, but here I'm just saying num equals int num to transform the string into integer form. The logic here comes in when we open up with an if statement and our one and only test. Now what this test is, to give you the high-level view, it's going to tell the user the absolute value of the integer that they enter. An absolute value is a real number regardless of its sign. Another note for those who are brand new to programming, I don't know if it's just the fact that many of us computer programmers are math geeks, or that these examples are particularly suited for the programming realm, but oftentimes you'll find sample code after you get beyond the hello world level deals with some element of mathematics, whether it's here it's absolute values, or later in this course we'll do Fibonacci sequences, but don't be surprised when you see that plethora of math-related example code. So the first test, as I said, is if the number given by the user is less than 0. Remember that less is non-inclusive, so this would not be 0. 0 would not be captured in this case. It would only be from -1 down through -2, -3, etc. The resulting output prints, string literal, the absolute value of space, the comma is the space, then it gives you the number from the user, another space, string literal is, another space, and then we just do the reverse signage. So if we give -3, the absolute value of that, of course, is 3. Else is our else condition, such that if we type anything else, the statement says the absolute value of our number is, and then it just simply echoes it. Now, if you're thinking like a computer scientist, and if you're thinking like a Python programmer, you're already thinking of things like, well, what if a user puts in a float? What if a user puts in text rather than a number? Let's open the run prompt and run this module. It asks us for an integer. First, let's do positive case. Absolute value of 2 is 2. No big surprise there. Let's run it again. And this time I'll do -4 as my integer, and sure enough, the absolute value of -4 is 4. So far, so good. Now let's run it with a special case or an exception. How about we throw in a? This is what's called an unhandled exception. We're getting a traceback from the Python interpreter, and the error says invalid literal for int with base 10a. Remember, you can right-click the code, select Go to Line, and idle will take us into the source file and bring us to the problematic line. And sure enough, the problem is here. When we call the int function, Python doesn't know how to handle a non-numeric input, you see? Final case, let's run the module, and let's put in a non-integer number like a float. Again, we're having conversion problems. So this is to get you thinking in terms of exception handling, which we're going to cover later in the course, and how to make sure that you've trapped everything that can possibly go wrong with your application to keep that application on track. Let's now look at our next example of if statements in Python. This one is a little bit more complex because we have some elifs here, so we're providing a wider scope of conditional logic here. By way of review, I want you to think about what the form's name is. Can you identify what data type this is right off the bat? I hope you know by now that this is, in fact, a list that consists of how many elements? 3 elements, indexed at 0, 1, and 2. Good. So this could be any sequence. I'm just chose a list arbitrarily, animal, mineral, and vegetable. Our answer name is the string result of this input statement. Are you animal, mineral, or vegetable? Note that I'm padding a space on the end there so that our response doesn't run right into that question mark. Now the logic comes in. Depending upon what the user does, whether they typed animal, mineral, or vegetable, the logic goes this way. First test, if the answer is form sub 0. So in other words, we're going into the form's name at index position 0 in the list. Here we print, you are an animal, grr. Now we could just as well variabilize this, but I just literally typed the word animal in this example. Elif, we do the position 1 case, mineral, you're a mineral. Elif, the second case, 0, 1, 2, you're a vegetable. If the user types anything else that doesn't match animal, mineral, or vegetable, we get you did not give a valid response. So let's test this out. I'm going to start out with mineral just for grins. You are a mineral, you must be healthy. So that's working just fine. Let's try something a little funky. Let's type minerals with an extra letter. You did not give a valid response. You see, this gives us the importance of testing our code to make sure that all off cases are picked up. Now, there are different ways that we can handle this. We're going to talk about one of them in the next example, actually. But we want to be always thinking about this. Outliers, they're called. If the person types animal, mineral, or vegetable exactly like that, they're good. But anything else, even including an S, in this case goes to the else, you did not give a valid response. Let's try this one more time. Are you an animal, mineral, or vegetable? I'll answer none. And again, it at least is handled in as much as it goes to the else. But remember, we always have to think about, well, what if we do mineral with an uppercase M? That's also going to go to the else, you see? In this next example, we're going to go a little bit farther yet in terms of trapping outliers to make sure that our code functions without exceptions. Here we're asking the user to continue yes or no. Now, you can be proactive on this front if you're expecting a particular response. Of course, this is only going to come to pass if this is a text-based or console application. It's actually easier when we're using graphical user interfaces because either a user clicks the yes button or the no button, and that's it. You see what I mean? But we could do something like this, where we're asking for a particular letter instead of the full word. Because right now it's not all that clear whether the user has to do full yes, full no, just capital Y, capital N, or if lowercase y or lowercase n would work. The good news here is that we're setting yn, our name, to lower using one of our string methods that we learned about earlier. And then our compound if block, we're first testing for y, then we're testing for n, and I'll talk about the spam in just a second. But why this is significant, friends, is check this out. We're using our substring syntax to check only the first character that comes back from the user, such that if yn sub 0 equals y, and it's gonna be lowercase, isn't it? Because we've forced that input into lowercase, we then do some code. If yn sub 0 is n, lowercase, then we don't care if it's n with gobbledygook after it. We come back with this code. This third example is an example of an Easter egg, or where you're handling a condition that's not explicitly referred to in your application. So if we were to type spam, we get this response back. This can be useful for you as a troubleshooter. You can put in diagnostic routines that are called by a certain keyword in this case, or you can just be funny and insert joke Easter eggs. But you want to be careful with that. Remember earlier in the course we talked about Microsoft and the trusted computing platform and them getting into trouble with the government a little bit because the program contained undocumented executable code. And then our else is our catch-all bucket. If the user does anything else besides put in y or n, they see this guy right here. You entered an invalid response. Let's run this code. Continue yes or no. I'm going to put in yes in all uppercase, and we get you typed yes. Now let's do something a little different. Nope. Because we're evaluating only the first character and forcing it into lowercase, it correctly gave us the response we wanted. Let's run again. Let's use our backdoor or our Easter egg. If we put in spam, we get that response. And finally, if we put something completely different, yes, no, I'll just say maybe, we get you entered an invalid response. I hope that this process of using the if statement is really clearing things up for you. It's a lot of fun to work with, quite honestly. We'll take a little breather from our code to come back to the whiteboard and consider Boolean logic, also called truth testing. According to Wikipedia, the Boolean or logical data type is a primitive data type having one of two values, true or false, intended to represent the truth values of logic and Boolean algebra. The word Boolean is kind of strange, oftentimes shortened to Boole, B-O-O-L, is named after its inventor, George Boole. He was an English mathematician and philosopher. We have to remember how important Boolean logic is. It's the basis of modern digital computer logic. And the way we're looking at it at this point in our Python program is that two names or two expressions can be ORed and or not. Now there's more than that to Boolean logic. We're just getting started. Basically, the OR construct says that if x is false, return y, otherwise return x. Now, if both of these are true, then both of them will be rounded up, or gathered up, I should say, not rounded up. The AND operator says that if x is false, return x, otherwise return y. Here, both conditions have to be true in order to pull back both x and y. The NOT Boolean operator says if x is false, return 1. That's used as a success error code. Otherwise, return 0. These are kind of geeky explanations. I think, for myself, and perhaps for you too, it's best to just give a demo to get a feel for how these work, and or not. They're pretty straightforward, actually. You can also test membership by using is-in or is-not. This can be useful as well in our Python program, and we've seen a little of that in previous nuggets, to test membership with in and is not. Before we go into the interpreter and work with Boolean operators, I want to do one more example of the if statement, just to really lock it in. Remember I told you that if is Python's sometimes called hacky way to implement the switch or the select case or case constructs in C and the .NET languages in particular. I also mentioned that there's another way to go, and that is using dictionaries. So here we have a dictionary. Remember, a dictionary is an unordered collection of key and value pairs. Dictionary called fmenu that has 3 items on that menu, spam, ham, and eggs, of course, how could we have anything else, with their corresponding prices. So we know what data type these are, of course. These are going to be floats, and the keys are going to be strings. CORDER is our name that gathers from the user the answer to the question, what will you have today, spam, ham, or eggs? Presumably, we're going to get back one of these 3 key values. So first, if the order evaluates to spam, we come back with the price of spam. Otherwise, if the order comes back with the key ham, we give them the total there. Instead of explicitly calling out eggs in an elif, which we certainly could, in this sample, I'm just saying the heck with it. If the individual types eggs or anything else, we're going to print eggs by default, your total is. Now, I also want you to see what's going on under the hood here when we're giving the results. So this first case, if the user selects spam, you know that the price is 1.50. We're having to hack around a little bit to format this because we don't want to give just 1.50. We want to make it look kind of presentable. So what we're going to do is bring in a string literal of a $sign, put in a space, although we don't have to, and then we're adding, you guessed it, a string formatting code. You'll remember this %sign syntax that we looked at in an earlier nugget, and what this is going to do is make sure that we're formatting to 2 decimal places. If we don't include this string formatting code, then what's going to happen is we're going to get 1.5 for the price of spam, 1.99 for ham, and 0.9 for eggs. And we're just not going to get what we want to see, okay? So this ensures 2 decimal places for our number, and then what we're retrieving here is the associated value that goes with the key spam. So to do this, you might remember when we did our methods for lists and dictionaries and tuples, there's a get method that works with dictionaries. where we can pass in one of those keys and get the associated value. So that's all we've got going on here. We're going to do a $, and then we're using string formatting to get the value of the first key and make sure that it's 2 decimal places. We do the same exact thing for the other cases. Let's run the module, and I'll say I'll have spam, and it tells us that'll be $1.50. Now I can fix this with the last comma, but I think you get the point here. We have the $, and the decimal places just like we want. Let's run it again, and I'm just going to say nothing. Remember, that's our outlier. And in the code, we said anything other than spam, ham, or eggs will evaluate 2 eggs, and it gives us the total. Pretty straightforward, but I hope you get the general idea. Now it's time to move to the Python shell. I'm just going to, for grins, open the shell menu and choose Restart Shell to clear out any names that might be in memory. And let's do a little exercise on Boolean logic. Why don't we create a few names? I'll create A at 50. I'll assign B to 25. I'll assign C to spam. And now let's run some Boolean tests to see what's going on. First, let's do A is equal to B. Is that true or false? Nope. How about A is greater than B? That's true. How about B is less than or equal to A? That's also true. You see how it works? Now, I promised you that you'd get a problem if you put in spaces between the angle bracket character and the equal sign. That's certainly true. How about A is not equal to B? That's true as well, isn't it? Certainly. A is 50, B is 25. Let's bring in a fourth name. We'll set D at 50, and then let's use, how about A is D? Now, is that surprising to you? Because A and D both point to the same exact data type and data value, although they are in fact separate components in memory, A as D did evaluate to true. So be aware of that. Let's bring in one more. E is eggs. And let's say C, which you'll remember is spam. C is not E. And of course that's true as well. The break and continue statements are useful in terms of helping you direct your program flow more strictly. Now, break and continue are used often with the if statement, but specifically, you can't use them just within an if block. They have to be used in a looping construct. And the 2 loops in Python are for loops and while loops. We're going to formally discuss those in the next nugget, so you're getting, again, kind of a little bit of a tease. Break is when Python interpreter hits a break statement, it's going to jump out of its closest enclosing loop and then continue the program. So it would jump out of a for loop or a while loop that was happening and then continue with the next statement in your code. Continue is a nice way to send your program from a particular nested substatement or statement block up to its closest enclosing loop. So whereas break is like, okay, we're out of this loop and continuing, continue simply repeats or iterates in that loop. So here we're seeing an example of break and continue in a while statement. Whereas for is more of a counting loop, while is used to constantly evaluate conditions. It's kind of like an if statement that's in motion. In other words, while a certain statement is true, while a certain expression is true, we have indented some additional statements. For instance, if, like I said, is oftentimes hand in glove used with for and while loops to further test a condition. So if test 2, if that is true, if test 2 evaluates to a Boolean true, then in this example, we break, and that takes us all the way out of the while loop and keeps us going. We keep on trucking with the program. You'll notice that what we've been doing thus far is, with our if blocks, the program just stops. In a more complex Python program, we might want to run a test and yet keep the program running, you see. Alternatively, we can do, I guess it would be an elif here and not an if, perform a further test and continue. The continue keyword would in this case take us back up to the while statement to make sure that whatever our initial test is still evaluating to true. While is going to terminate if and only if this initial test evaluates to false. You want to be careful with looping constructs such that you do have some termination condition. Otherwise, you wind up with the infamous infinite loop situation. Our final sample code in this nugget is another script that I'm actually going to run from an OS shell prompt to give us some experience with that. And actually, this program works a lot better when you're running it from the OS. I'll show you why. where we open things up with a while. Now, normally a while statement is used in conjunction with a specific expression. To just say while true is a little bit of a hack. You run the risk of creating an infinite loop when you just say while true, unless your subcode, your indented blocks, eventually will come up with a Boolean false. I also put this comment in here just to give you a good example of how to use inline comments. Notice that as long as you're using the pound sign, you can insert a one-line comment anywhere in your code, even in the all-important header line of a compound statement. So while true, we're assigning the new name s to the result of an input function. Enter a string of at least 4 characters, or, let me continue this over, or the user can type Q to quit the program. At that same level of indentation, we're saying if s is Q, we're going to break out of the while loop, and in this case it'll terminate the program. Otherwise, we want to test the length. Remember, our condition here is to enter a string of at least 4 characters. So if the len, we're already familiar with this function, of course. This gives us the character length of that name, s, is less than 4, so this would be 3 characters or fewer. We come back with value is too small and continue. Continue is going to take us back up to the top. The condition here is still true, so the user will be prompted to enter the string again. The implied else here is that if the string is at least 4 characters, we print the string is of sufficient length, and then we actually formally end this program. There's a couple calls that you can use to end a Python program. We're going to talk about these in detail a little bit later, of course, but one that I use a lot is the raise system exit. This is going to just quit the program. Before we run this from a command line, I'm going to run it once from the interactive prompt, and I'm going to enter a string of at least 4 characters. 1, 2, 3, 4. And it gives us the appropriate feedback. The string was of sufficient length, and we have quit, but we get a traceback. Now, it's not an error, actually. You'll notice we don't see a value error statement, but it can be a little bit frightening or a little bit off-putting to a new programmer thinking that he or she has called that system exit function wrong, when that's in fact not the case at all. So let's go out to an OS shell prompt and run this script. This is if5.py. There it is right there. So I'll call Python with if5.py, enter a string of at least 4 characters, or Q to quit. Well, how about I do 3 characters? Value is too small. Enter a string of at least 4 characters, or Q to quit. 1, 2, 3, 4. The string was of sufficient length, and notice that the system exit call worked just fine. Let me up arrow to recall the previous command, go back into the program, and let's just make sure that if I use the Q, it also quits the program. Good and good. Control Flow Part 1 of 2 Review. In this nugget, we greatly expanded our programming repertoire by examining the if statement and how it, along with Boolean operators, can make our program proceed among a predetermined number of paths depending upon our program and business needs. We then looked at one way, among many, of course, to rein in or throttle the flow of our Python program. Namely, we learned how to use break to break out of a for or while loop, and continue to reset that loop, depending upon, again, what we want the program to do. I hope that this has been informative for you, and I'd like to thank you for viewing.